Okay, does everybody have a seat? Okay, thanks for coming. My name is Aaron Margosis. I'm here to talk about something I call Defense Against the Dark Ages. Your old web apps are trying to kill you. I'm a principal consultant. I work in the U.S. federal practice, so I work primarily with U.S. government customers, but I work with a number of other groups as well. I see a lot of people moving to new versions of Internet Explorer and Windows 7, and I'm trying to help them get more secure as part of the process. I'm also the co-author of the Sysinternals Administrator's Reference, which is a book that documents all the Sysinternals utilities. I co-authored this with Mark Rusinovich. Everyone heard of Mark, I assume, right? Okay. Are you going to his sessions? Go see his sessions, especially Case of the Unexplained. If you've never been to a Case of the Unexplained, that's the session you want to see. I'm sure many of you are familiar with the Sysinternals utilities, Process Explorer, Process Monitor, Auto Runs, and a variety of others. This book is the first time a lot of those have been properly documented. So, we're going to have a book signing this Friday at the MS Press O'Reilly booth down at the Expo. So if you bring a copy of the book, Mark and I can sign it. Of course, somebody in their infinite wisdom decided that TechEd Europe was not going to have a bookstore. So you have to go find bookstores around in Amsterdam that carry our book. But to help make up for that, O'Reilly is going to be giving away 25 copies of the book to the first 25 people in line. So be ready for that. Oh, and everybody else who's in line will get a coupon for a free MS Press book, or O'Reilly book. I can't remember now. Also, Mark Rusinovich will be there. He'll be signing copies of his novel Zero Day and the new Windows internals book, which documents the internals of Windows 7 and Server 2008 R2. So, why did I put this session together, and why do I think it would be useful for you to be here and listen to it? What I want to do is call attention to some risky practices in web apps that are not already commonly looked at, that are commonly overlooked, not considered that big a deal. So I'm not going to cover things like SQL injection, which is very well known as a common vulnerability in a web app. I want you to be able to persuade managers and developers of the importance of making some of these changes that I'm going to recommend, and to articulate the options that are available to you. The scenarios where I see this coming up the most, one is when you're upgrading Windows or Internet Explorer. Because what happens then is you tend to get the default settings instead of the heavily modified settings that you had had over years of having XP deployed. And with the default settings, all of a sudden, a lot of things break because security is often loosened in the process of maintaining an image in an environment. So when people upgrade, they often see things just not working. Plus, also, Windows 7 changes a whole lot of stuff about how applications interact with the operating system. I also see it come up when people want to just do a security review and say, we want to tighten security. What are some things we should look at here? So the three things I'm going to be talking about today. Number one, very, very high risk. Applications that insist on a particular old, unpatched version of Java. Second, knowingly or unknowingly carrying old Internet Explorer settings forward from older versions of Internet Explorer. And finally, one that is a rather insidious risk, and that is using ActiveX controls that are not marked safe for scripting in web applications. I'll describe what all that means. What I'm not going to cover are a lot of the very common things. If you ever look at the top 10 web app vulnerability lists, it always includes SQL injection, cross-site scripting, predictable cookie values, using HTTP when you should be using HTTPS, right, to protect the content. These are very well-known problems, and the documentation out there is plentiful for fixing those. If you do want to find out more about those things, and they are very important, this is the #1 book I would recommend. This is written by Mike Howard, David LeBlanc, and John Viega, the 24 Deadly Sins of Software Security. This is a very easy-to-read book. It takes 24 different types of vulnerabilities that are very common in applications, web applications and other types of applications, and very easily breaks it down into here's the pattern, and here's the different languages you can fall into a problem with, here's how you can fix those problems, and then you move on to the next chapter. If you only read 2 or 3 chapters out of this book, you'll come out way ahead. It'll be worth the price of the book. Another very valuable book, and the one that describes how Microsoft has done secure coding over the past 10 years, is Writing Secure Code by Mike Howard and David LeBlanc. This is the 2nd edition. In addition, there's also Writing Secure Code for Windows Vista. This one is an addition to Writing Secure Code that talks specifically about issues particular to Windows Vista and the new security model that Windows Vista introduced, including integrity levels and user account control and things like that. And then if you want, all those are for developers primarily. If you want to get deeper, the security development lifecycle describes how Microsoft has gone about making code more secure, making our products more secure from design on up. And this really applies to managers as well as to developers. So those ought to fill the gaps of issues that I'm not going to talk about today. So let's talk about Java. It has been left on the shelf a little too long. It's starting to smell bad. The issue comes about because of application compatibility. Application compatibility can be defined as you write an application on a particular platform, and everything's working fine, and then something about the platform changes. You introduce a new version of the runtime engine, the Java runtime, or a new operating system, or a service pack to an operating system, and all of a sudden, the app doesn't work anymore. That's application compatibility, right? So the inventors of Java had a really brilliant idea, and it was this. You write an app for a particular version of Java. You test it, it works, you get to keep that version forever. You can install new versions of Java onto the machine without replacing the old one, right? So they can live side by side. And a program that was designed to run with a particular version can specify, I need this particular version, and it gets that particular version. The program continues to work exactly the way it had when it was designed and written for the first time. And in the 1990s, when they came up with this, it was a really good idea. Because, you know, on the Windows side in particular, we had this thing called DLL hell, where you update some component, and all of a sudden, apps break all over the place. And so Java, the inventors of Java had a really good idea with this. Does anybody see the problem with this, though? The problem is these older versions also contain security vulnerabilities. And so by leaving these things around, the vulnerabilities are not getting fixed. Maybe they are in the new version, but any application or any malware can specify, I want that old version that has the vulnerability that I can exploit. And so this happens all the time now. Many, if not most, Java runtime engine updates contain critical patch updates that fix vulnerabilities. So you cannot keep the older versions and be protected against the vulnerabilities that were fixed. Not only that, when a vulnerability is discovered in the latest version of Java, very often that vulnerability has been around for a while, and it can also apply to older versions that are no longer being looked at or no longer being supported. The Java support lifecycle is very short. 1.5, aka 5.0, support for that, free support, ended in October of 2009. And 1.6, which is still very, very widely used, is going to be out of support this November. The only way you get patches is if you pay Oracle for them. Java 7 just came out, and in July of 2014, it's end of life as well. It's not going to get patched anymore past that point. So Java has now become the most widely attacked component on Windows. Early 2010, Symantec reported a notable rise in Java vulnerabilities through the end of 2009. And in 2010, the Security Intelligence Report from Microsoft, which uses telemetry, it gathers data from real systems around the world, noted a very sudden, very massive spike in actual exploit attempts of Java on Windows computers around the world. And we have seen those high levels continue ever since. And it is now the most widely attacked component on Windows. This graphic comes from the latest Security Intelligence Report. And you can see Java right here where the arrow's pointing. And there's this other thing, HTML/JavaScript. I asked them about that, and they're kind of conflating the numbers there a little bit. HTML JavaScript just means this is the delivery mechanism that was used. It's not exploiting vulnerabilities in any particular implementations of JavaScript. It's just got an iframe that uses JavaScript to point the user, the victim, to a particular website that contains malicious code that then attacks some other component, such as Java or Flash or Excel or some other vulnerable component. So Java still remains the most widely attacked component on the Windows platform. So a customer asked me not too long ago, they said, we've tested all our apps with Java 1.6 Update 17. Is it okay to stick with that? Okay, Update 17 came out near the end of 2009. So sticking with Update 17 is kind of like saying we deployed Windows in November of 2009. We're not going to patch it. How many of you would be willing to do that? Deploy Windows and not patch it for 2.5 years. That's basically what you're doing. And in that time, 142 separate vulnerabilities have been patched in Java. So you're basically saying, here's 142 different ways to attack us because we're keeping this really old version of Java around. There's something special about Update 17 because I've seen that in a few different places. Also, another thing about this is that if you stick with something like Update 17, you can't go to Internet Explorer 9 because versions of Java before Update 25 were not compatible. 25 was the first one that supported that. This is from the Security Intelligence Report, and it shows that the exploit being used the most exploits something that is available in Update 17. This was a vulnerability that came out in 2010, and it was fixed after Update 17 shipped. And this is the most widely used avenue into attacking Java on Windows computers. Oh, and by the way, this one here, February 2012. You've heard of the botnet on the Apple computers? So what happened was Oracle came out with they come out with patches once every 3 months. You know, very similar to the way Microsoft has Patch Tuesday. Oracle does it every 3 months on a reliable schedule. Oracle came out with patches in February 2012 for Java. Apple Computer has their own implementation based on Oracle's, but they're responsible for releasing patches to Java on the Apple platform, and they dragged their feet for 6 weeks. You know, why not? You know, nobody attacks Java, and Apple is perfectly safe, right? Apple's perfectly safe. You know, nobody attacks Apple because they're better than Microsoft. So all of a sudden, you know, the attackers started exploiting stuff that was patched in February 2012, and next thing you know, 500,000 to 1 million Apple computers are infected with this botnet, or have joined this botnet with using a vulnerability that was patched in February 2012. So Oracle, or rather Sun, it was Sun's Java at the time, used to recommend, you know, it's perfectly okay to have these versions side by side. That's no longer the case. Everyone cares more about security now than they did back then. Oracle now says, we highly recommend that you remove older versions of Java. Use only the latest version of Java. They also say, so a lot of people say, if we install a new version of Java, everything's going to break. We haven't tested everything with the new version of Java. Oracle says, I'm not a Java developer, so I don't have a lot of direct experience with this. But they say versions are backward compatible. So if you install new versions of Java, your programs should continue to work fine, as long as you're not specifically demanding a particular version. If you have something written in your code that says, I need update 17, there's nothing we can do about that. Nothing anybody can do about that. So don't demand a specific version. Just rely on the version of Java that's available. If you're using documented best practices for writing Java code, you should be able to run on the latest version of Java. One thing that a friend of mine who's a Java developer pointed out was there are these low-level libraries, sun.misc and com.sun. They're really, really old stuff, and they're very tightly coupled to particular versions of Java. They will often break. So don't rely on those old lower-level libraries. And they also are no longer needed because the Java libraries that are available today are much more full-featured, and so you don't need some of the stuff that was provided by those older classes. In Windows, we have app-compat shims, where if you have an application that says, I need Windows XP Service Pack 1, we can apply an app-compat shim that lies to the application. So that when it checks the Windows version, we can say, yes, this is XP Service Pack 1. And yes, you're running with admin rights. Even though you're running on Windows 7 Service Pack 1 without admin rights, we can lie to the application about all that stuff. Java, as far as I know, has no such equivalent mechanism for lying to an application that's demanding a particular version. So you do need to go in, modify the code to fix those. But ideally, updating Java and installing Java patches should be as uneventful as deploying Windows patches. Right? You don't have to retest everything in the universe every time you apply a patch. Next topic, any questions about the Java stuff? Okay, carrying old Internet Explorer settings forward. We see customers wanting to just, they want to move to the latest version, but they want to keep everything exactly the way it was before. It's kind of a conundrum, I guess. And things we've seen customers doing include copying IE settings from older versions, sometimes intentionally, sometimes unintentionally. Turning off Internet Explorer protected mode or turning off user account control to get apps to work. And I'll talk about some of the issues there. And turning off data execution prevention, also known as NX. So I've seen this a lot of times. Here's the environment. We're using MDT or something like that to build a new desktop image. We're building Windows 7, and here's all the stuff we're putting into it. And oftentimes, there's this .reg file that contains a bunch of settings that were collected and have been applied to every version of Windows they've been using for years. And nobody knows what's in them, because it looks like this. And you say, well, what is this setting for? Well, it's obvious. It's pretty much self-documenting. 1406, it's an URL action that means access data across domains. And the value 0 is enable. You knew this, right? Yeah. So I have these discussions with customers, and I keep having to say, look, if you don't know what the settings are for, you should probably take them out, because they're probably going to break stuff. Another way that I've seen customers move old settings forward is using Internet Explorer maintenance. Internet Explorer maintenance is from the earliest days of Windows configuration management, of centrally managing computers throughout an enterprise. This comes from the 90s. Okay? And what you would do is you bring up this UI, and you go to security zones, and you import the current security zones and privacy settings. When you do that, on the machine that you're doing that on, it's sucking up all the values. Now, if you're doing this on Windows 2000 with IE 5.01, you're getting all the IE 5 settings sucking them up, and then pushing them out to your machines. And if you never update this, you're pushing IE5 settings onto your IE9 and IE10 device. Well, I guess no one's really running IE10 yet, but IE8, IE9. So is this a bad thing? Oh, by the way, Internet Explorer maintenance is gone in Windows 8, finally removed. The thing is, default settings have improved. Default security has improved over the years. Here's a tool. I'll demonstrate this tool in just a moment, called Internet Explorer Zone Analyzer, IE Zone Analyzer. And it shows, here's a bunch of differences between XP with IE6 and Windows 7 with IE8. And all these settings have been locked down in the trusted site zone, in the internet zone. A bunch of different stuff is now more secure than it was. And if you keep bringing forward the IE5 settings, you're not getting the benefit of that. Let me demonstrate this tool, because I think this thing is, might be of value to you. This is available on my blog. If you get the deck, the URL is in there. This tool has saved me a lot of time. So particularly on a machine where you've got settings locked down through group policy, if you have any group policy settings and you try to look in the security dialog to see what the settings are, and it says settings are established by your administrator and you can't see what the settings are, you know, that dialog won't show you things that are set by policy. This tool will. So for example, it can show you, here are the effective settings for the intranet zone on the local computer. And it shows all the settings and where they're from. These are set in user preferences. Some are set in machine preferences. You can save these settings and then copy them to another machine and do comparisons. So I've got a bunch of different settings that I've saved here. And we can see here on a U.S. government system, using the U.S. government policies that are mandated for the internet zone, here's all the settings and here's where they're coming from. Everything is machine settings or machine policy. This is a great tool when a policy is supposed to be applied and you're testing and things aren't working the way you expect. You can use this tool to verify, did the settings actually come down the way they were supposed to? Not only that, you can use this to compare different settings. So you can see, for example, the comparison between IE8 intranet zone and compare that to the IE6 intranet zone. And it'll show differences in the effective settings. And here, where it's gray on one side, it means there's no setting on that for that system. And where it's yellow, there is no yellow here. Let's clear this list. We'll do trusted sites because that was a big one. Going from IE6 to IE8, and let's compare that against local settings also. So you can add as many things into the list as you want. And you can see all the differences between the zones. So you can see when you're going from trusted sites to intranet zone, what are the differences between those? And this makes it very visible. You can also export to Excel. So you can save that and print it out and do other things. This also has a map URL to zone, so you can enter a URL and see what zone it's in as well. And it also has a zone map viewer, so you can see what is explicitly defined to be in a particular security zone on your system. And it looks at things like what is overridden because it's in a place that is not being looked at. So as part of building this, I had to do a lot of analysis and figure out, you know, there's lots of different places in the registry where these settings are established. And some of them are ignored depending on system settings, like the use-only machine settings group policy ignores everything under HKey current user. But if you're just looking through the registry, it's hard to see that. So this tool will help bring out that kind of information. Any questions about IE Zone Analyzer? Does it look good? Does it look useful? Anybody excited? Everybody's really hungry or hungover. So protected mode was introduced in Windows Vista with IE 7. And it's a defense in depth mechanism that when a site is running in protected mode, basically the browser is not allowed to modify large areas of the registry of the file system. So this helps protect against malware that tries to drop stuff onto your system and then run it every single time you log on. So something running protected mode or low integrity cannot write to the start menu. It cannot write to the run key in the registry. It can't write to your documents folder, a variety of things like that. So it does protect against a lot of malicious activity that's out there. It's turned off for the intranet and trusted site zone because those are places where, yes, I want to be able to run code that drops stuff in my documents folder in my desktop and things like that. So it's a per zone setting. You can turn this on or off on a per zone setting or on a per zone basis. Turning off user account control turns it off completely. Okay? So the thing is, if you have applications that use Java or ActiveX that does stuff on your desktop and tries to write to the documents folder, those things will often break if you're running with protected mode on. So the thing is that if you have a URL, if you have an internal site that is something dot something else dot mycompany dot UK or something like that, that's going to be internet zone. Because if it has dots in the name, by default, Internet Explorer is going to say that's an internet site, regardless of what the domain is on your machine. You have to explicitly go into group policy or some other mechanism to specify these domains need to be considered intranet or trusted sites. So make sure those are set correctly. What we've seen, though, is customers run into the problem, apps don't work, and they find if we turn off protected mode for the internet zone, the app works. Or if we turn off user account control, the app works. That's like just taking the doors off the hinges and just leaving the house wide open. So don't turn off protected mode, especially in the internet zone, and don't turn off UAC. Turning off data execution prevention, also known as no execute. What does DEP do? DEP makes apps crash. That's what its function is. That is a feature, not a bug. We want those apps to crash. Because what it's doing is there's different parts of memory. There's places where you have data, and there's places where you have executable code. And what you can treat them all as equivalent. And in the past, our computers did that. You could just create some create a data buffer and fill it with stuff that could be considered executable code that has machine instructions in it, then point the CPU's instruction pointer to that and execute that code. Java does that, for example, right? Because it's just-in-time compiling its stuff to run, using Java bytecode converts to machine code at runtime. Same with .NET, does the exact same thing. The thing is, attackers exploit this too. So we've heard of buffer overruns. Everyone heard of buffer overruns? So what happens there is you've got a big data buffer, but your code isn't handling it correctly. And an attacker submits a larger amount of data than your program was expecting, causes your app to malfunction, and ends up executing stuff that the attacker just submitted, which is actually in a data portion of memory. So what DEP does is it says we can mark pieces of memory, sections of memory, to say this is readable only, this is writable, or this is executable. If it's writable and executable, then that's a potential problem. So you don't see that very often. Let me show you what that looks like. Here's a sysinternals tool called VMMap. And we'll take a look at the virtual memory of Windows Explorer. Okay, so here's all the different portions of memory. Image memory is stuff typically loaded in from EXEs and DLLs and OCXs. It's primarily executable code. And you can see here that everything is pretty much executable and readable, but not writable. So if a program tries to write to these portions of memory, it's going to crash. Not through dep, but just because you're not allowed to write to that portion of memory. In here, if you open some of these up, you may see some things that are read-write. You know, these are data sections within the executable, okay, but they're not executable. So you should never see anything that is executable and writable. Compare that to the stack, which is all read, write, and guard pages. A guard page, when you hit a guard page and try to write to it, it allocates more stack for you. So it dynamically uses up more memory rather than committing it all at once. But again, the stack is not executable. So if you push data into the stack and then try to execute it, you'll get a dep crash, and it'll cause your app to crash, which is a good thing. So why do we see apps crashing? There's three types of things that can be in that memory that can cause a dep crash. One is malicious code. An attacker has specifically attacked your system and pushed malicious code into a data area and then tried to execute it through a heap spray, a buffer overrun, something like that. Yeah, it's better if the app crashes and stops completely rather than execute any of that attacker's code, right? We hope so. It might be non-malicious code. For example, like I said earlier, Java and .NET will create code on the fly and then execute it. Those programs should, when they create that area, create the code and then change the protection on it from writable to read and execute, and then go and execute that code. Newer versions of Java do that. Older versions don't. The Microsoft JVM does not. The Microsoft JVM went away long before dep became popular. And I have a customer who was having these dep crashes, and I asked for a crash dump. We got the crash dump, and MSJVM was in there. And they didn't even know they had it installed. But there you go. So they wanted to turn off dep, and we said, that's probably not a good idea. The third possibility is, other than non-malicious code and malicious code, is it's just garbage. The program did something wrong. The instruction pointer is pointing someplace totally random. It's totally lost. It's probably going to crash anyway, right? Because it's not pointing. It ran off the rails, and it's trying to execute something that is nothing. So it's probably going to crash anyway. So if dep crashes it, that's fine. So don't turn off dep, because it does protect you against a lot of the common hacker techniques that are still being used. In Internet Explorer, we pretty much always find dep crashes are caused by add-ons. Browser helper objects, ActiveX controls, toolbars, things like that. If you turn those off or take those out one at a time, you might see your crashes go away. You can isolate what is causing the problem and then get it fixed, if you actually need that component around. Any questions about carrying old IE settings forward? Third topic I want to cover, using unsafe ActiveX in web applications. So what's ActiveX? ActiveX has a really bad reputation. Everyone thinks ActiveX is just inherently unsafe, because an ActiveX control is actually x86 code that can do anything that the end user can do, right? And so lots of vulnerabilities have been triggered through ActiveX. It's a way of running native code on somebody else's machine. But really, it's a software reuse technology built on the component object model and object linking and embedding, also known as OLE. ActiveX controls are often scriptable, meaning you can use VB script or JavaScript or PowerShell or something like that to load these components and execute them. And they can be really, really, really useful for doing a lot of system management tasks. The problem is there are some where you don't want to allow web apps to be able to have that functionality, but you do want your management tools to be able to use those. And so years ago, we came up with a concept called safe for scripting. Safe for scripting and initialization, which basically means, let me describe this a little bit further. Internet Explorer uses this as its plug-in model. Okay? Every browser has something that allows you to extend the browser and do more stuff. Because before HTML5 made lots of things possible, this was the only way. HTML back in the mid-90s was severely limited. There was only so much you could do with it. And so Java came up with, you can use Java components to extend the capability of the browser. We came up with ActiveX. I believe Mozilla has a plug-in model as well. So as I was saying, safe for scripting basically distinguishes between ActiveX that is okay for general use, like within scripts and management scripts and VBA, Word macros and stuff like that, as opposed to stuff you want to allow a website to dictate. You don't want to allow a website to be able to do anything on your computer that the end user is allowed to do. So safe for scripting, when a component is marked safe for scripting, the developer is saying the use of this ActiveX control will not harm the end user. Okay? It can display stuff to the end user. It can collect some data that the user types in, but it's not going to delete all their documents. Unless that's what it's specifically supposed to do, and the user is supposed to click a button to, yes, clean up my documents folder or something like that. So if by default, if an ActiveX control is not marked safe for scripting, Internet Explorer won't load it. Okay? Unless the security setting is relaxed. There's a security setting that allows you to say, yeah, we want to be able to use unsafe ActiveX. And that setting is initialize and script ActiveX control is not marked as safe for scripting. You can set this on a per zone basis. And it is disabled in all zones, including the internet zone, intranet, trusted sites, etc., except for the computer zone. Local stuff that's running on your local computer, it will prompt you before it uses those. So our security guidance and U.S. government security guidance and pretty much everybody's security guidance mandates disabling this setting in the internet zone. In the internet zone, if you're following the security guidance, you will never turn this on because you don't want to allow sites on the internet to be able to run arbitrary code on your computer when you browse a site. So what is not safe for scripting? Examples are Microsoft Word. Right? Microsoft Word has a very rich programmatic interface. You can do lots of stuff with it. You can build documents on an end user's machine just using script and treating Word as an ActiveX control. You can use the spell checker as an ActiveX control. The thing is, the Word scripting model is so rich, it allows you to do anything you want to do. You can launch additional programs from Word. So that's not exactly safe for scripting. The Windows script host is a great component for doing management. You can create files, you can delete files, you can manage the registry using Windows script host, tons of stuff you can do with it. Again, not something you want to allow web pages to be able to do. The thing about this is you may have a web application that was designed to use one of these components. It's not possible to enable just one unsafe ActiveX component without enabling all of them. So if you want to use Microsoft Word, okay, you're also enabling Windows script host, scripting components, etc. Also, when you enable it within the zone, you're enabling it for all sites within the zone. So it's not like we want to allow this web app on this server to be able to do that. You're enabling it for the entire intranet or all of trusted sites. So why would anybody ever relax this setting? Again, until very recently, straight HTML, you could only do so much. How many of you ever need to generate Word documents on the fly from an application? Yeah. And how do you do that from the server? You can't. Oh, I take that back. Until Office 2007, you couldn't. WinWord.exe does not run on the server. It will not run as a service. right? It has to run on an end user's interactive desktop. That's the only way it can run. So if you want to create Word and Excel documents from a web app, it's got to be done on the client until Office 2007 and the new Open Office XML file formats, which are XML-based. Another thing about it also is that this setting has not always been forbidden. The trusted site zone before IE7, in IE7, trusted sites got locked down a whole lot. Intranet zone is now the most permissive of the zones. But prior to IE7, initialize and script ActiveX controls not marked as safe for scripting was set to prompt. So if you tried to launch Word or something like that, end user would get one of these. One of these very helpful prompts. So consider the end user now. The end user is reading the dialog and says, an ActiveX control on this page might be unsafe to interact with other parts of the page. Do you want to allow this? Now, the security-conscious end user is thinking, what other parts of the page? The menu? The company logo? No. That never happened, right? Because the security-conscious end user doesn't exist. There's no such thing. It's a mythical creature, the security-conscious end user. No. The end user looks at the dialog and it says to the end user, I'm in your way. Do whatever it takes to make this dialog go away. Do you want this dialog to go away? What's the answer? End user clicks yes. And so as a result, having it set to prompt is pretty much the same as just saying yes. And so rather than inconvenience the end user, the administrators eventually say, just turn it to enable. Make the dialog go away. Which makes a lot of sense, right? So let's consider. Let's say you've got an in-house web developer who's greedy, disgruntled, of questionable moral character. All he can control, let's say it's Roger Grimes, for example. Bad guy, right? Seriously evil guy. Let's say this guy has control over some part of the company's internal web page, homepage, right? Everybody logs in the morning, opens up the browser, and it goes to your company's intranet site and gives them the news of the day. And there's a part of the page that's pictures and some news and stuff like that. And that's the only thing this web developer has access to is the stuff that populates that part of the page. He's not a help desk admin, and he's not a domain admin or anything like that. He has no access to end users' computers. All he can do is create content for the organization's internal homepage. So if unsafe ActiveX is not allowed, what can he do? Not a whole lot. If unsafe ActiveX is enabled for the intranet zone, all he has to do is change a few lines in some obscure script file somewhere on that page. It feeds into that page to download some executables into a particular place in the user's profile, right? Create some files. So now when the user logs on, he's running stuff that Roger Grimes put on that guy's computer, right? And it's spying on the user, sending documents to a competitor, for example. He does this for just a couple days, and then he takes the script that he modified and sets it back to the way it was. Nobody even knows they've been infected for months. And then they're starting to wonder, what's this stuff on our system? And how did it get there? How are they going to ever figure out that it was this guy? Good luck figuring out what the root cause was. So when I bring this up with customers, I often hear, look, we've had this setting enabled this way. We've never had any trouble with it. How do you know? And even if that's correct, even if you haven't had any problems with it, how do you know you can say the same thing next week? I recommend you go see Roger's talk. When is your talk? Oh, it's today. Right, at 2:45? At 2:45, go see Roger Grimes' session, and it's called, it's a cybersecurity talk. I can't hear you, but what works in cybersecurity? Something like that. Okay, so he's going to talk about a lot of this kind of stuff, the insider attacks, the targeted attacks, the advanced persistent threats, or now what we're now calling determined adversary something or other. I can't keep up anymore. So this stuff is becoming an increasing threat. Oh, and by the way, Metasploit is a tool for building, supposed to be for the good guys to test the systems they're on and do penetration testing, but it's also used by hackers to build malware. Right? It's a framework that allows you to plug in stuff that exploits lots of different vulnerabilities. And they've had one for a long time for this particular configuration problem. This exploit takes advantage of the initialize and script ActiveX controls not marked safe for scripting setting within Internet Explorer, and they helpfully point out this security flaw is not uncommon in corporate environments for the intranet or trusted site zone, and very exploitable, easy to exploit. Okay, so maybe I've convinced you that you need to look at this and take this problem seriously. So what do? It's going to depend on the app. Every web app that depends on unsafe ActiveX has a different reason for doing it. I had one customer, like I said, most of my customers are U.S. federal government. So what can I say about them and still be polite and be allowed back in the country when I go home? They don't always make the best decisions for the best reasons. Let's just put it that way. They had this one web page where they had a text box on the web page, and they wanted to pre-populate it with the end user's domain/username. And I said, okay, well, that's easy. All you need to do is capture it on the server using Windows Authentication. You know who the user is. Just push that back into the web page when you populate it. And they said, sorry, no, it's not IIS. It's okay. How about just make the user type it one time? Then the app saves it in a cookie, and then every time the user comes back to the page, you read the cookie and you put that in there. And they said, no, it has to be like this every single time. It's part of the specification. Fine. So I suggested a custom ActiveX. I'll come back to this in just a moment. Because the thing is, if you enable the use of wscript.network, you're opening up the world. Anything that the end user can do, anything in the intranet site will be, in the intranet zone will be able to as well. But the most common example I see is office automation. So one solution here is to create the content on the server. Now that Office OpenXML is available, you can create content on the server using libraries that are freely available and create PowerPoint, Word, and Excel documents using these libraries. You don't need to install Office on the server. You're just building XML using the OpenOffice XML, standardized file formats. Turns out that's not as easy as you might think. The XML spec for Office documents is pretty heavy. And the tools that Microsoft ships are not mature yet. Let me just put it that way. I've got some colleagues who are working on this exact problem. And they looked at there's a bunch of open source libraries that are available. If you go to codeproject.org, there's a whole bunch of, there's a number of different libraries that make it easier to write OpenOffice XML. The thing is, some of the licenses of the open source, some of them are the GNU license. We in Microsoft are not allowed to touch anything that has that particular open source license. There's some open sources that we are allowed to use, but GNU is not one of them. But those kinds of things can help you. But my colleagues are basically rewriting from scratch, and they're having a heck of a time with it. So as a short-term bridge, I suggested that they write a custom ActiveX instead. And you must be thinking, he's out of his mind, right? Write a custom ActiveX. The idea here is you've got all this logic in the web page. And it's using various components. What you can do is just take that logic, encapsulate it into a custom ActiveX that just performs what you really need the web page to be able to do, like create a document. So you create an ActiveX that just has that interface. I'll demonstrate it in a little bit. So you're minimizing what the ActiveX can do. It can't do harm to the end user. It just does what the app actually needs it to be able to do. You can also lock it down further using site lock or per site ActiveX, where you can, using various techniques, say this control can only be used by this site. And Internet Explorer will respect that and not allow other sites to load that ActiveX control. One of the benefits of this is it minimizes the changes to the existing web app architecture. If you have something where you're generating Word docs and Excel documents, and you go to OpenOffice XML, and you start generating that from the server, you're basically rewriting everything. The server architecture is going to change. You're moving all the logic up to the server and writing all new code. With this, you're taking your existing code. You're still doing the same work on the client. You're just wrapping it in a slightly different way. I consider this a short-term bridge. ActiveX is ultimately going to go away. We're starting to see, with Apple's browser no longer allowing Flash, all those kinds of binary plugins are going to go away. And in Windows 8, you've got the two versions of the browser, the Metro browser and the desktop browser. The desktop browser will still run ActiveX. The Metro browser will not. So ActiveX is going to go away, but this is a valuable short-term bridge, because the thing is, when you're talking about fixing a security problem, and you say, how much is it going to cost me to fix this security problem? And you say, well, it's going to be $1 million to get you to where the app does what it's already doing, but in a slightly more in a more secure way. That's kind of a hard conversation to have. So if you can say, this is something we can do, it's very inexpensive, and it's very quick, and we get better security right away, then that becomes a different conversation. Here's a graphic to demonstrate what I'm talking about. Today, you've got an unsafe ActiveX. Your app uses that component. It can be abused to do other things as well. But instead, what I'm suggesting is you write something that is safe for scripting. It can do whatever you need it to do, but you only expose the interfaces that the app actually needs. And so the web page cannot access unsafe capabilities. So how do you build an ActiveX today? The fully supported way is to use Visual C++. And you can use ActiveX template library to build ActiveX. It helps a lot. There are some drawbacks to this. Number one, for the word automation problem, you need someone, first of all, who knows how to write C++, and who knows how to use ATL, and who knows how to automate Word and Excel using C++. And that is possible, but the number of people who can do that is smaller than the number of people who can do it other ways that I'll discuss. I personally like this way, but it does take a little bit more effort. Another way that's somewhat supported is to do it using C# or VB.NET. The thing is, we don't really recommend this practice. We don't recommend loading managed code, C# and VB.NET, into hosting processes like Internet Explorer, because you can only load one version. Like if you've got 1.1, you can't load anything with 2.0 or 3.5. And there are browser toolbar helper objects and things like that. So you might run into some problems. There's also a performance issue. Loading the .NET runtime can take some time as well. What I've recommended to some customers the fastest and easiest way to do it is to use VB6. And this is heresy. This is probably, when's the last time someone spoke at a TechEd and recommended using VB6? It was before many of you were born, I'm sure. But the thing is, one thing that VB6 was really, really good at was, one, automating Office. Because VBA, visual, if you wrote macros, you're using something that's very like VB6, right? You hit F12, or no, Alt F11 to bring up the macro editor. That's VB, right? I mean, VB, I used to hate it, but then I started using it. It was like, this is so cute. This is such a cute development environment. You can just build all this stuff really quickly. But it's really productive for certain tasks, including this one. Now, the thing is this supported? And the answer is kind of, right? So VB6, the development environment, came out in 1998. It's not supported anywhere, right? It's long out of support. Does that mean it doesn't work? It works great on XP. It still works great on XP. Doesn't work so well on Windows 7. If you run it with admin rights, it might work, but it's never really been tested there because it was already out of support when Windows 7 shipped. But, I don't know if you've noticed this, but if you look in the System32 folder, MSVB VM 60.dll is part of Windows. It's part of Windows 7. It's part of Windows 8, which means VB apps still run. And the VB runtime is going to be kept supported. Because it shipped with the operating system, it's going to be supported as long as that version of Windows is supported. So if you build an app that depends on the VB runtime, it should run perfectly fine as long as you're not trying to do admin stuff from a non-admin context or something like that. It should run perfectly fine. And the thing is here, lots more people know VB6 than know C++. So, I love this demo. You're leaving at the best part, I promise you. Actually, the best part was when I was playing Lucinda Williams earlier. Let's see here. I'm on the wrong machine. Let me go over to the XP machine. Okay, so here's our old Internet Explorer on Windows XP. And let's take a look at Internet options. We'll go to the intranet. We see here that I've got this intranet site this site here in the intranet zone. Let's look here. Because this system's been around for a while, I've got initialize and script ActiveX controls not marked as safe for scripting set to enable. So I go to my website, and what I need to do is I need to create a Word document. And I can just click a button, and it automates Word. And wants me to activate, but I'm not going to. Okay, so how did I do that? Let's look at the source. Here's the content I want to push in, the greeting, fax, phone, etc. And I'm creating this scripting object, shell.application, which allows me to do anything. I go into the program files folder and get this template. I launch Microsoft Word. I add a document using that template, and then I push in the values. Okay? So is that bad? Well, the thing is, because I can do that, I can do anything else. I can launch arbitrary programs on the end user's computer. Let's take a look at that real quick. See here, wscript.shell run arbitrary code. So what I want to do is I want to get to a place where instead of allowing all this, I want to have a simple ActiveX control called my Word doc automation doc creator that has a method called new equity fax doc. I push in the values, and that's all the thing allows me to do. Because I can mark that safe for scripting. So, bring up VB. I've got this skeleton project all ready to go. I've got this component I'm creating. I've got the method. It takes these values. How do I write that code? This is really easy. I'm just going to take this subroutine copy it, paste, save, build, done. It's a little hard to do this with VB.NET because see all these variables I'm declaring here? You need to actually set a type. VB script, it's all typeless, so you don't say this is a string and this is a document and things like that. In VB.NET, you have to declare them. In VB6, you didn't have to. So let's see if that works. Let's go over to my system over here where I've got the DLL. I've got a little PowerShell script that marks the DLL safe for scripting. I run this do install. Okay, it registers the DLL and then puts in some registry values that say this component is safe for scripting. Internet Explorer, go to the page. And I can verify here. Now, down here, I've got the F12 developer tools. This is Internet Explorer 8, because I didn't put 9 on it yet. But the developer tools are really, really valuable for seeing all kinds of stuff that's going on. Oh, wait, no, this is i9. I'm sorry. Very full-featured set of tools that come with every version of Internet Explorer. You just press F12, this comes up, and you can do all kinds of stuff with it, including when I try to do this, I can see the error message, permission denied. Because this system this is set to the default. Initialize and script ActiveX controls not marked as safe, disable. I don't want to allow that. So that means that I can't launch arbitrary code. ActiveX component cannot create that object. But because I've installed this component that's safe for scripting, I can do it the safe way. There it is. So now Roger Grimes cannot hack my machine through that website that he manages. And that was pretty quick. That's a fairly low-cost migration from a very insecure status to a much more secure status. Any questions about that? Yes, question. How do you deploy the ActiveX? Yeah, you'd need to install on every machine. You would, as long as you've got something like SCCM or some other mechanism that you can deploy a file, run regserve32, mark it safe for scripting. You need admin rights on the boxes in order to do that. But it should be fairly straightforward to do that. I would recommend just take that component and just drop it somewhere under program files and register it there. Any other questions? Was it fun seeing VB6 again? So now, hopefully, you can identify some risky practices that maybe you weren't aware of that are riskier, perhaps, than you realized. Maybe you're going to take this back and persuade others, we need to fix these problems, particularly the Java one, because that is being widely exploited. And you've got some options that are available. A couple references. I've written about the Java forward compatibility issues in a bit more detail on the FDCC blog. FDCC is Federal Desktop Core Configuration, a project I work on. There's a great document about understanding the internals of data execution prevention written by Eric Lawrence, a security PM on the Internet Explorer team, who I always regularly rely on for valuable information. His blog is really excellent. I've written about the initialize and script ActiveX controls issue on on the blog as well. And if you want to see the security intelligence report, there's the URL for that. And with that, 9 minutes remaining, open for questions, or I can give you back 9 minutes of your life, whichever you prefer. Okay, well, thank you very much for coming. I hope you enjoyed it. Hope you found it valuable and intriguing and everything. Look for me around if you want to talk about stuff. Also, I've got another session on Friday morning, the sysinternals primer gems, where I'm going to talk about a bunch of Windows internal stuff and some of the sysinternals tools that expose some of that stuff. So that's Friday 10:15, I think, in the theater. Thank you again.